All right, guys. So this video, we're going to talk about mole conversions. All right. So converting from other units to moles and converting from moles to different units such as mass, volume, number of particles, whatever it may be. All right. And hopefully you had a chance to watch the previous video, which talked about dimension analysis, and which it's more like a tool that we could use to convert back and forth. But here we're going to talk about mole conversions and the unit conversions with using the chemical aspect of moles. All right, and so molar mass, all right, and we kind of talked about molar mass already. It's basically, it's the mass of any particle when you have 1 mole of it. So if you have exactly 1 mole of any particle, what is its mass? All right, and that number we simply call the molar mass. Now, the cool thing about molar mass, it also allows us to convert from mass of a substance to moles of a substance, or vice versa. Like, for example, like if you look at the periodic table and you're trying to figure out the molar mass of carbon, right? So the molar mass of carbon, so we have the molar mass of carbon. If you look at the periodic table, it's simply 12.011 grams per mole, okay? So basically this right here is the equivalent statement, okay? So the equivalent statement that represents this here, all right, the EQ statement, all right, is for every 1 mole of carbon, it has the mass of 12.01 grams, okay, of carbon. So what does that mean then? Well, it's kind of sloppy. All right, anyways, so what does that mean then? Well, let's just say if you had 2 moles of carbon, what would be the mass? Well, if 1 mole of carbon is 12.011 grams, then obviously if you have 2 moles of carbon, then it will be 24.022 grams of carbon. Okay. What about if you had 3 moles of carbon? What would be its mass? Well, you'll multiply all this by 3 essentially, and you'll get 36.033 grams of carbon. And that's the relationship, because we know the general relationship, if we only have 1 mole of carbon, is that its mass is 12.011 grams. And that's the ratio. All right. And so whatever we multiply the number of moles with, we will multiply the grams with that same number as well. All right. And so the reason why this is kind of easy that we talked about, because I just use whole number ratios. But what if I give you something that's not as easy, or no set of numbers that's not simply easy? Like, for example, let's just say if I were to ask you, all right, what is the mass of 0.323 moles of carbon? Okay. Same idea, but the numbers are a little bit different. We can't just do this from the top of our heads. So dimensional analysis is a really good tool to help us kind of figure this out, because all you're really doing, you're just converting from one unit to the next. We're converting essentially moles to mass. And really, when we're talking about mass, we're specifically talking about grams. All right. That's really kind of like the cut on that one. I'm just going to rewrite this. But we're really talking about grams here. Okay? So that's the unit we're going from. We're going from moles to grams. Okay? And so now, if we're going from moles to grams, what is the EQ statement? What's the equivalent statement? What do we know? What's the relationship between the moles of carbon and the grams of carbon? What do we know? Well, we know, based off of the periodic table, that for every 1 mole of carbon, we have 12.011 grams of carbon. So we could use this EQ statement to help answer this question here. Okay, and so just like the previous video, every time you have an EQ statement, you need to write out your possible conversion factors. So what are the possible conversion factors in this case? Well, the conversion factors could be either 12.011 grams of carbon over 1 mole of carbon, or 1 mole of carbon over 12.011 grams of carbon. Now, be sure you always write the units. I know oftentimes we get kind of lazy and we just leave the numbers as is and forget to write the units. But the units it's what's kind of help us to drive which way to go and how to answer these questions correctly. So take the extra second, extra 2 seconds, the extra lead, the extra ink, write the units down. That way you could clearly see where you're going, and hopefully you have a better chance of getting these problems correct. All right, so I wrote out, so we have our two conversion factors, our two possible conversion factors. So we just got to figure out which one to use. All right. And so let's decipher this. So hopefully you see that we're going from, once again, moles of a substance to mass or grams of that particular substance. So let's go ahead and write out the problem. So the problem is 0.323 moles of C. All right. So now we got to figure out which conversion we got to use. Well, we're trying to cancel out moles. So this unit needs to show up on the bottom here. So which conversion factor is the one that we need to use? Well, hopefully you can see that this is the correct one, and we don't need this one at all. So 1 mole of carbon at the bottom, 12.011 grams of carbon at the top. All right. And then all you have to do after that is just plug this into the calculator. But first, we just got to make sure we cancel our units. So moles of carbon all canceled out. We're left with grams of carbon, and that's what we want. The question is asking, what is the mass of carbon? What is the grams of carbon? So then all we have to do is that in your calculator, you got 0.33 times 12.011. And so when you plug that into the calculator, and hopefully you could do it correctly, you'll get 3.88 grams of carbon. And that's your answer, okay? So let's try a different example. So let's say, we're trying to figure out how many atoms of aluminum are in 2.32 moles. Mole sample. All right, so we're just trying to figure out how many atoms of aluminum do we have in 2.32 moles. So the first thing we need to figure out is, okay, what relationship are between these two units? And what two units are we talking about? Well, we're talking about moles and atoms. All right, so how many moles and how many substances? Remember, we talked about moles. When we're looking at moles, so we're looking at how many moles to atoms, okay? Remember, 1 mole of any substance or 1 mole of atom is 6.02 times 10 to the 23 atoms, all right, of aluminum. All right, and this is true with any substance. Remember, mole is a counting unit, all right? So if you have a pair of something, it's always 2. If you have trio, it's always 3. If you have a mole of something, you always have 6.02 times 10 to the 23rd. All right. And so in this case, I'm asking how many atoms of aluminum do I have in 2.32 moles? Well, we know the EQ statement. All right. We know that for every 1 mole of anything, but in this example, aluminum, we have 6.02 times 10 to the 23rd atoms of aluminum. Okay. So we have that. So that's our equivalent statement. Now let's come up with our conversion factors. So what possible conversion factors can we come up with? Well, there's 2. Hopefully you know that. So the 2 possible conversion factor is that you can either have 1 mole of aluminum over 6.02 times 10 to the 23rd atoms of aluminum, or 6.02 times 10 to the 23rd atoms of aluminum over 1 mole of aluminum. Okay, so these 2 are your conversion factors. Which one you use depends on the question. So let's kind of go back and look at the question at hand. So it's asking you how many atoms of aluminum are in 2.32 moles sample. Okay, so what we're going to do, we start out with our 2.32 moles sample of aluminum. So which conversion factor will be best for our problem? So if you notice, we're trying to get rid of moles of aluminum. So which one is best to get rid of moles of aluminum? The one where moles of aluminum is a denominator. The conversion factor where the moles of aluminum is the denominator. And so in this case, it'll be this one and not this one. So I'm going to rewrite this conversion factor as so. So we have 6.02 times 10 to the 23rd atoms of aluminum over 1 mole of aluminum. Okay, so moles of aluminum will cancel out. You're left with atoms of aluminum. And then all you have to do really in your calculator, you have 2.32 times 6.02 times 10 to the 23rd. And so you need to make sure you include all of that when you type it in the calculator. And once you do, you should get the answer 1.40 times 10 to the 24 atoms of aluminum. Okay, so here, same idea with dimension analysis, but this time we're converting from moles of something to the number of atoms of something using 6.02 times 10 to the 23rd. Okay? All right, let's try a different example. So let's just say we want to convert 1.34 times 10 to the 21 atoms of copper to moles of copper. Okay, this is what we want to do. Okay, so essentially, if you pay attention, all right, look at the units. The two units that we're dealing with. We're dealing with atoms of copper to moles of copper. All right, and so that's what we want to do. All right, so we're going atoms of Cu to moles of Cu. So what equivalence statement basically expresses the relationship between atoms of copper and moles of copper? Well, we do know that for every 1 mole of copper, there are 6.02 times 10 to the 23rd atoms of copper. That's our equivalence statement, okay? That's what we know. So from here, let's come up with our conversion factors, our two possible conversion factors. So you can either have 1 mole of copper over 6.02 times 10 to the 23rd atoms of copper, or 6.02 times 10 to the 23rd atoms of copper over 1 mole of copper. So now we just got to figure out which conversion factor do we need, or which conversion factor we're going to use to answer this problem. Okay, and so just kind of going back to the problem, you see that you have convert 1.34 times 10 to the 21st atoms of copper, and we're going to moles of copper. So we'll start out as, so we have 1.34 times 10 to the 21st atoms of copper, and we want to get rid of atoms of copper. So we're going to use not this one, but this one, this conversion factor. Okay, because this conversion factor, you have 1 mole of copper on top, 6.02 times 10 to the 23rd atoms of copper in the bottom, and hopefully you see that atoms of copper will cancel out, and then all you have to do is just do the math itself. So in your calculators, you're going to type 1.34 times 10 to the 21st times 1, and you're going to divide it by 6.02 times 10 to the 23. Now, what you need to make sure you do for this type of problem, depending on the calculator and depending on how you type this in, you need to make sure that you put this in parentheses. So that way your calculator can see this all as one number instead of 2. Okay? And then so when you type this in correctly, you should see that you get 2.23 times 10 to the negative third, or 0.00223 moles of copper. All right, and that would be the answer there. Now, let's talk about another conversion that we haven't talked about yet. So this one's kind of new. All right, so it turns out that if you have 1 mole of a particular gas, okay, and usually most gases, so if you have 1 mole of a gas, okay, at STP, okay, and this is only true at when this gas is at this particular environment, and this environment we call it STP. All right, and to be more specific, when we're talking about STP, that means it's S stands for standard temperature pressure. Okay, so standard temperature pressure. So at a very specific temperature and a very specific pressure. All right, if we have 1 mole of something, and I will continue on the rest of this statement, but STP, basically that standard temperature is 0 degrees Celsius, and that standard pressure is 1 atm. So when this mole of gas, all right, has at a temperature of 0 degrees Celsius and is under pressure of 1 atm, it occupies the volume of 22.4 liters. Okay? So basically, what I'm saying here is at STP, 1 mole of a gas is equal to 22.4, or occupies the space of 22.4 liters. Okay? So, all right, let's go over an example problem so that we could put this into context. Okay, so what volume will 3.25 moles of helium, He, will occupy at STP? So the most important thing, this is only true at STP, okay? And I guess during this unit in our class, when we're talking about these type of problems, it's always going to be at STP, all right? We'll talk about the exceptions in another unit. But at STP, okay? And so what units are we talking about here, okay? So we're talking about volume, and usually when we're talking about volume, we're talking about liters, okay? So we're going from volume, or going to volume from moles. So this is your conversion factor, moles and liters. So at STP, what's the what's the EQ statement? So the EQ statement that we just talked about is that for every 1 mole of He, okay, occupies 22.4 liters. All right, that's our EQ statement. Okay, and it's from here we could develop our conversion factors. So our conversion factor would be for 1 mole of helium over 22.4 mole. Not moles, but 22 liters of helium, or 22.4 liters of helium over 1 mole of helium. Okay, so these are our conversion factors that we have for this problem. So let's go ahead and solve the problem. So we have 3.25 moles of He. Okay, so we're going to liters. We're trying to figure out how many occupies, what's the volume that this amount of moles occupy. All right, so we start off with moles here, so that simply means that we need to cancel out the mole, and this mole must be a denominator, so this has to be our unit, or our conversion. So 22.4 liters of He over 1 mole of He. All right, and so then we could cancel these out. Okay, and then we could simply just do the math itself. And so when we do the math, or when you type this into the calculator, you will see that you have 3.25 times 22.4. All right, and then when you put this in your calculator correctly, hopefully you should get 72.8 liters of helium. So that's basically what it occupies. Now, I know this has been a long video, but hopefully you notice certain connections. All right. So hopefully you notice that there is relationships between 1 mole of a substance and all these different types of measurements. Okay. So like, for example, we have 1 mole of a substance equals to, you have the molar mass. All right, so how much it weighs in grams. All right, and this, we typically find this number from the periodic table. Okay, hopefully you also notice that for every 1 mole of a substance, you have 6.02 times 10 to the 23rd particles of that substance. All right, and when we talk about particles, we could be talking about, atoms. So like when we talk about individual atoms such as, copper, aluminum, carbon, oxygen, sulfur. All right, so these what we mean by atoms. All right, these are examples of them. We could also talk, when we're talking about particles, we could be talking about molecules. All right, now molecules, basically we're talking about covalent compounds. Okay, so two nonmetals joined together, so like CO2, NO2, CH4, any two nonmetals bonded together. Or we could be talking about what we call formula units. Okay, so formula units, all in all, are basically ionic compounds. And so example of ionic compounds are your metals and nonmetals. So like NaCl, MgO, let's say KCl, SrBr2. So these are all ionic compounds. So they're considered to be formula units. But all in all falls under this umbrella particle. So don't get that confused. So if you see atoms, molecules, formula units, we're looking at particles. Okay? So anyways, kind of going back, so we have 1 mole is equal to 6.02 times 10 to the 23rd of these particles, okay? And hopefully you notice that at STP, 1 mole of a substance is equal to 22.4, occupies 22.4 liters of it, all right? And so if you notice, if you kind of pay attention, is that basically the common theme of it all is 1 mole. And all these things will equal to one another as long as you have 1 mole. And so here we can actually create a giant equivalence statement, all right, where 1 mole of any substance is equal to the molar mass, all right? And so that's the grams that we typically find from the periodic table. So that's the number, the average atomic number, mass, from the periodic table, okay? It's equal to the molar volume, all right? And the molar volume is basically telling you when you're at STP, all right, this unit is in liters, and that this number is always 22.4, and 1 mole is always equal to what we call Avogadro's number. Now, Avogadro's number is, the units is typically particles, and this particles could be either atoms, molecules, or formula units. But this number is 6.02 times 10 to the 23rd. All right, and the reason why I call it Avogadro's number is because of Avogadro. He's the one who pretty much first pinned this number. So, in reference to this man, we call it Avogadro's number. But anyways, this is the ratio, okay? So 1 mole is equal to the molar mass, which is equal to the molar volume, which is also equal to Avogadro's number. And really, you could just, all you have to do, just kind of memorize this or just know this, and you could answer legit any conversion problems, either going from moles to molar mass, or mass to volume, or Avogadro's number to volume, or moles to particles, or whatever it may be. We could use this same equivalent statement. We just got to pull out the things that we need, okay? So let me give you an example of what I'm talking about here, all right? So just kind of having this on top. So let's just say I want to know the mass in grams if I have 1.11 times 10 to the 24 molecules of CO2. Okay, so let's kind of think about what units are we dealing with. So the units that we have are grams, or mass in grams, and molecules of CO2. All right, and then we could go back and look at our equivalent statement or our main equivalent statement and see, okay, exactly what we're looking at here. What are we talking about? So mass in grams, so we're talking about the molar mass here because it's in grams, okay? And we also looking at molecules, and remember, molecules is just a special type of particle here. So we're trying to find what's the equivalent statement between grams and particles, okay? So we could figure that out. So the numbers that we need here is, first, we need to figure out what is the molar mass. And this molar mass, you find that number from the periodic table. And then the number for particles is really simply but 6.02 times 10 to the 23rd. Okay, so let's first figure out what's the molar mass of carbon. And so when you go to the periodic table, you see that carbon is 12.001 grams. That's the molar mass of carbon. The molar mass of oxygen is 15.999, and there's 2 of them. Okay, so when we add this up, we get 44.009 grams of CO2. Okay, so the equivalent statement that we're going to use for this problem is 44.009 grams of CO2 equals 6.02 times 10 to the 23rd molecules of CO2. So once again, guys, please write your units, okay? So now that we have these equivalent statements, all right, let's go ahead and write our conversion factors. So our conversion factor that we're going to use, possible conversion factors, we have 44.009 grams of CO2 over 6.02 times 10 to the 23rd molecules of CO2, or 6.02 times 10 to the 23rd molecules of CO2 over 44.009 grams of CO2. So now the question is, which conversion factor you're going to use? Well, let's go ahead and set up our problem. So the problem that we have is 1.11 times 10 to the 24 molecules of CO2, all right? And we're trying to see, okay, which conversion we're going to use. I'm kind of scroll this up so I have room. All right, so then here's molecules of CO2. We need to cancel that out. So we know that whatever conversion factor that have this on the bottom is the one that we use. And hopefully you notice that it's going to be this one and not this one. All right, so we're going to write this out. 44.009 grams of CO2 over 6.02 times 10 to the 23rd molecules of CO2. Molecules of CO2 will cancel themselves out, and so all you have to do in your calculator, carefully type this number, 1.11 times 10 to the 24 times 44.009 divided by 6.02 times 10 to the 23rd. Now, just be sure, anytime you're dealing with scientific notation, is always best, good practice, put these in parentheses, so that way you don't mess this up putting this in the calculator. All right. And then this will give you your final answer once you put this all in. Okay. And so in this case, you should get the answer 3.26 times 10 to the 3rd grams of CO2. All right. And that's your answer for this case. All right. And it's just, I know this is a long video, but, I just want to make sure that, I kind of cover all the bases, and then, in class we'll go over in more detail. All right, now let's just go through one more example, okay? Still using that main EQ statement. So let's just say that we have, I want to know how many molecules of Br2 occupy 52.4 liter container at STP. Okay. That's what we want to figure out. That's what we want to know. All right. So let's just kind of go back and highlight the units that we're talking about. So we're looking at molecules of Br2, and we're looking at 52.liters of Br2. So we're going from liters to molecules. Okay. So we're going from liters to molecules. So we need to know what EQ statement, for our main EQ statement, that will help us solve this problem. Well, we do know at STP, most importantly, at STP, 22.4 liters of any substance, all right, is basically equal to, all right, is equal to 6.02 times 10 to the 23 of that particular substance. So in this case, we're talking about molecules of Br2 molecules. Okay, so we got 22.4 liters of Br2 is equal to 6.02 times 10 to 23 molecules of Br2. So let's go ahead and write our conversion factors. All right, so our two possible conversion factors are, we got 22.4 liters of Br2 over 6.02 times 10 to the 23 molecules of Br2, or we have 6.02 times 10 to the 23 molecules of Br2 over 22.4 liters of Br2. Okay, so these are the two conversion factors that we're going to use for this particular problem. And this problem, once again, we're going from 52.4 liters to molecules. Okay, and so let's just kind of go back. So 52.4 liters of Br2 multiplied by what? What conversion factor we're going to use to help us figure this thing out? So you notice got liters of Br2. So are we going to use this one? Are we going to use this one? Hopefully you could quickly figure out that this is the right one and it's not this conversion factor. So 6.02 times 10 to the 23rd molecules of Br2 over 22.4 liters of Br2. Okay, so liters of Br2 will cancel out. And then you'll simply, mathematically, in your calculators, 52.4 times 6.02 times 10 to the 23rd divided by 22.4 liters. And so when you plug this into your calculator, you should get 1.41 times 10 to the 24 molecules of bromine. All right, and so that's the big rundown on mole conversions.